Practical exercise 3. Keeping organized with large digital circuits. In this exercise, we will be working with complex digital circuits which will demand both excellent spatial organization on the breadboard and good knowledge of the binary addition system. Part 1. In Part 1, we will build a circuit around a demultiplexer IC. The demultiplexer, or demux for short, is a device that takes in one input and returns two to the nth power outputs. The demux has an n number of selector lines, which control the output. In this experiment, the outputs are controlled by push buttons and visualized with LED lights. The combination of buttons in the video are very unclear. The X's and zeros in the bottom left corner show which buttons are being pushed. Part 2. In Part 2, we will build a 7-segment display driven by 555 timer and witness the effect that the capacitor and resistors have on the timer. When the voltage input goes through the 555 timer, it charges up the capacitor. The comparator releases the voltage when the negative input has a higher voltage than the positive, which happens when the capacitor is fully charged. What affects the time between pulses is the capacitance of the capacitor, or if the voltage is reduced due to increased resistance or a decrease of voltage input. When the push button is connected to pin 2 in the IC 4026 or the trigger pin, we force the IC to get high input. That triggers the output and the 7-segment display starts to count independently of the capacitor and the timer. When we connect the push button to pin 15 in the IC 4026, which is the reset pin, we force the voltage to the ground and the IC resets. Part 3. In Part 3, we will connect a circuit to a serial connection of D flip-flops to create a shift register. A register is essentially a collection of 2 or more flip-flops used to store data. The shift register in this experiment is called a serial in, parallel out shift register. When the button is pushed very quickly, the capacitor isn't guaranteed to get the charge he needs to give high on its output. It has to be fully charged when the clock pulse occurs. When we hold the button for 1 clock pulse, we let the capacitor charge up and he gives the 7474 IC high input, which holds that for a clock pulse and then sends it to the next input in the 7474 and so on. In each of these steps, a LED lights up to see the output in each clock pulse. The results are exactly how we expected it to work. We had a few problems but found out that our 555 timer was not working like it should have. After we switched it out, the circuit worked perfectly. Practical exercise 4. PPG, or this. Practical exercise 4 aims to introduce students to the world of biomedical engineering with the construction of something that is both clinically relevant, and relatively straightforward and inexpensive. Part 1. In Part 1, we will build PPG using infrared light and several classic devices. First, we built a simple circuit just to see if the TCTR1000 sensor is working. Here you can see the circuit and the sensor, which is working fine. Here are the calculations. First for high pass filter and then for low pass filter. The sensor is very sensitive and can detect movement from some distance. Next was the test. Both members in a group have a medical history relating to the heart. One had supraventricular tachycardia, or SVT, which is an abnormal fast heart rhythm arising from improper electrical activity in the upper part of the heart. And the other went through a chemotherapy which had to be stopped due to enlarging heart, resulting in high resting pulse. Part 2. In Part 2, we will make the same circuit that we made in Practical 3 Part 2, but instead of 555 timer, we will use the PPT and our pulse as the timer. First, we recorded the pulse we had after a short time of sitting, and then again after a few push-ups. As expected, the heart rate increased after the physical exercise. When we were searching for signal, we definitely found a difference between persons.
Já. Já.